Sir, isn't it?
Yeah.
What's the coefficient of friction formula?
Well, force of friction equals mu force normal, right?
Yeah.
That's it.
So is the centripetal force that was in to force of friction?
It would have to be equal, right? And minimally to hold them in place, that would have to be what it would be, right?
Is centripetal force still in newtons on there?
Yes. It's measured in newtons. How much force is necessary to make a turn? Okay, 7.5 number 2. I should be doing fast. Forces.
What is centripetal acceleration in? Like,
That'd be meters per second squared. It's how fast you're falling towards the center. Mass is 10. 10 kilogram. Boy, what are you doing that? Experiments on 10 kilogram people. I had 62.5 newtons for number 2. Is that right?
yeah.
Okay. And then this welcome left the cat on the bag. What force is holding us in place for number 2?
Friction.
Friction. And so therefore, force centripetal is equal to force of friction because that's what's holding us in place. We know the force of centripetal we already solved for, so this is just mu force normal. So 62.5 equals mu times 10 times 9.8, because force normal is equal to your weight if you're on a horizontal surface. Divide that out. How about mu would have to be equal to about 0.638, otherwise the child is going to be launched. Now, is that good? All right. Acceleration, because I'm pulling, it pulls it to this direction instead. So the object actually travels like this. And then it wants to travel like this, but I pull it in. It wants to travel like this, but I pull it in towards the center. So it is accelerating towards the center, but the effect is not that it's going faster or slower. The effect is it's changing directions. Fair enough?
Yeah.
When you think about it, you actually are going faster or slower because when you get to the back end over here, which direction are you traveling? As if you stopped and came back the other way.
Yeah.
Just like acceleration does.
Okay.
Right? If I got negative acceleration, I'd come to a stop, and then I'd start backing up.
Okay, that makes sense.
All right, I promised somebody I'd do like 13 problems already. I wasn't even starting ready. So 7, 8, 9, we gotta do?
Yeah.
All right, 7. You have to remember this formula. It's really, 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 really important. If I want the speed of a rocket, I'm given a radius and a time. I'm going to go, the velocity is equal to 2 pi r, the circumference of a circle. Is W with me?
Yeah.
Was this US for 7?
Yeah.
Divided by the time it takes to do it, correct? So, in this case, it would be 2 pi, whatever the radius of the string is or whatever it is we're swinging. It's a sling. So it is 1.2 meters long. Divided by the time it takes to do it, which is 0.16. Right? That's how fast it has to be going. And so I get 39.3 meters per second. Are we in agreement? No, you don't like that.
I didn't get that.
I did not get.
Okay, let me see what I typed in wrong.
That's just 2 pi divided by 1.16.
It asks for velocity, speed of the rock, so we have the radius in there already. It didn't ask for angular velocity, it asked for speed.
So you only did. Oh wait, what?
So you didn't multiply through 5.
So I could either do omega, which is 2 pi over t, which would be 2 times, hold on a second, pi divided by 0.16. So my angle,
I got
I didn't multiply by 1.2. Is that what you're saying?
Yes.
Okay, thank you. So my angular velocity is 39.3, which means I got to multiply by the radius to get the. Thank you. You guys can teach me the class later. Please submit your notes. It takes a while for me to figure these things out. Okay, good. Okay, so that's the linear velocity. Okay. Then the question is, what's the acceleration of the rock? Acceleration of the rock is going to be towards the center. What kind of acceleration does it have to be to make it go in a circle? Centripetal acceleration. So centripetal acceleration should be v squared over r. That's going to be equal to 47.1 squared over the radius, which is 1.2.
Really big number.
It is going to be a really big number. You're whipping that rock around pretty fast. Every 0.1 seconds, or every 10/6 of a second is going around this person's body. It's hauling. It's fast. Squared divided by 1.2, and then I got a question for Mr. Combs. Combs.
Do I need to convert 120 is that kilometers an hour? Something?
Probably.
Do I convert that
Yep.
to seconds?
Meters per second, right?
Meters per second.
Everything meters in seconds.
Conversion for that.
You've got to go through what 1,000 meters is 1 kilometer, and 60 seconds in a minute, 60 seconds
So
in a
I
minute.
just multiply by 1,000.
Yeah, you got to multiply by 1,000, then divide by 60. Is that right? No, it's divide by 1,000. No. What the heck? I'm doing it wrong. You multiply by 3.6, but that's not what we're going to do. We're going to write it down right. 120 kilometers per hour,
Yeah.
where 1 kilometer is 1,000 meters. You can multiply by that. Where 1 hour, there you go, is 60 seconds. Where, 60 minutes. Where 1 minute is 60 seconds. Ready, Hootie? That's the starting of number 10. Anybody need tension and a string for number 9, or you guys got it? Multiply by mass, you get the tension and string. Welcome, good?
Yeah, I didn't convert the kilometers.
Oh. Forsooth.